For this first problem, you're going to calculate the area between y equals 3x and y equals x squared minus 18. So first you have to find the limits of integration. So you set both y equations equal to each other, and then you factor, and you're going to get x equals 6 and x equals negative 3. The area equation is whatever function is on top subtracted by the function on the bottom. And we know x squared minus 18 is going to be in the negative axis, so we put that on bottom. Then you're going to get the integral from negative 3 to 6 of 3x minus x squared minus 18. So then you do the integrals, super easy, split it up, 3x squared over 2 from negative 3 to 6 minus x cubed over 3 from the same boundaries, and then minus 18x. And then you do all this math, and you should get negative 189 over 2. I'm not expecting you to get that far. I just want to see that you know how to do the integral and you know what numbers to plug in and subtract. So it shouldn't be too bad. But yeah, I may have even done the math wrong. Oh well. Happy Thursday. So for number 2, we're going to be using the washer method to find the area between y equals e to the x over 2 and y equals e to the negative 2x. So in order to find the volume of the functions, you are going to be integrating the area. And for a washer method, your equation is pi f of x squared because you're going in a circle. It's a washer method. So our equation is going to look like v equals, from the limits of a natural log of 2 to natural log of 4, because those are given, times pi, and then in parentheses, you're going to subtract your values squared. So in this case, we know that e to the x over 2 is going to be the positive function, e to the negative 2x is the negative function, so we know that that's going to be on bottom. So you're going to subtract e to the negative 2x from e to the x over 2, and then square the whole thing. So then you end up with pi times the integral of e to the x minus e to the negative 4x. All I did was simplify the squares. And so then you integrate e to the x, which is just e to the x, and you integrate e to the negative 4x, and you plug in u equals negative 4x, and then your du is negative 4 dx. And you know that in order to make the functions equal to one another, you have to multiply by negative 1/4 in the front. So you do that, and you get negative 1/4 times e to the negative 4x as your end result from the same limits of integration at the beginning. And then after that, you do all of your calculations. For the first one, you should get 2, and then for the second one, you're going to get something crazy like 1/4 times 1 over 256 minus 116. All multiplied by pi, and I just want you to leave your answer like that. It'll make it a lot easier on me. Okay, so for this next problem, it says a cylindrical tank with length of 10 meters and a radius of 5 meters is on its side and half full of gasoline. How much work is required to empty the tank through an outlet pipe at the top of the tank? Gives you the density, so we already know that. So the best technique to start with is to draw a picture. So I drew a picture of a tank on its side, it's half full, and I made a new origin from y equals 0 to 5 and negative 5. So you know that that equation for the radius of that part of the circle in my picture is the square root of 25 minus y squared. We know that the work equation, this is something you have to memorize. The work equation is from A to B times the density and gravity and the area and the distance. So, and the density and the gravity will be given. So we know that the width of the cylinder is 2r, which I have written at the bottom, and you'll see that in a second. But basically, the width is 2 times the radius, which we found was the square root of 25 minus y squared. So we'll end up being 2 times the square root of 25 minus y squared. And if you're wondering how we got the square root of 25 minus y squared, all you're doing in that equation is you're solving for x, because you know that your whole integral is in terms of y. So you're just going to solve for x in a regular equation, x squared plus y squared equals r squared. And then you'll get the answer, which is the square root of 25 minus y squared. So as I mentioned earlier, the width of the cylinder is 2 times r, which is 2 root 25, or the square root of 25 minus y squared, which you can now see. And then the cross-section area is the length times the width So we multiply by 10 and we get 20 square root of 25 minus y squared. So then you have to find the distance required to reach the top of the tank. And because we changed the origin, the distance is 5 minus y. So therefore, your work equation would be 737 times 9.8 from the boundaries of -5 to 0, because you changed the origin and that's half full, to 0 is half full, times 20, or 20 times the square root of 25 minus y squared, times 5 minus y dy. This will get you 80% credit. Okay, so then you multiply the constants together, and then you're actually going to distribute the 5 minus y, so then you're going to get an integral that's 5 times the square root of 25 minus y squared, which is actually equivalent to a quarter of a circle, so that's why I skipped the step and went 5 times 25 pi over 4. But then the other one is y times the square root of 25 minus y squared, in which you would use u substitution to equal 25 minus y squared, and your du would be -2y. And then you multiply the front by -1/2 in order to make it equal, and then you get down to the bottom, and you see my answer is 375 pi plus 500 over 12. Okay, so for this one, we're going to be using the shell method to find the volume of the solid between these two functions when it's revolved around the x-axis. So we know that for the shell method, our equation is 2 pi y or x, indicative of whichever axis it's revolved around. If it's revolved around the x-axis, it's going to be in terms of y. If it's revolved around the y-axis, it's going to be in terms of x. So first, we have to solve for x, because our function has to be in terms of y. So that's why you see my volume function is from 0 to 2, because y equals 2. Times 2 pi y, all multiplied by y squared plus 2, because I solved for x in the y equals square root of x minus 2 equation, and I got y squared plus 2. Also, I'm sorry about whatever is on my paper. I have no idea what's on it, but something got on it, so I apologize. Anyway, after that, it's pretty smooth sailing, so I take the 2 pi out, and then I distribute, and I get y cubed plus 2y dy. I separate, and then I integrate, which is y to the 4th over 4 from 0 to 2, and then 2y squared over 2, which ends up just being y squared from 0 to 2, all multiplied by 2 pi. And then as you do all that math, you end up with 32 pi over 4 plus 8 pi, which is equivalent to 16 pi. Okay, so for this one, we're going to be calculating the length of the curve from 0 to the natural log of 2 of f of x equals 2 times e to the x plus 1/8 e to the negative x. So we have to memorize our equation for that, and that is the integral of the square root of 1 plus f prime of x squared, just the f prime of x part squared, from a to b. So first we have to find f prime of x, and we know how to do that. That's pretty simple. It's just 2 e to the x, and then in your exponent you have a negative, so you have to bring that down. And you get -1/8 e to the negative x. Then you have to find f prime x squared. All you do is square it, and then you go back to your equation, you plug f prime of x squared in, and you get 1 plus 4 e to the 2x minus 1/2 plus 1/64 e to the negative 2x, and you have to simplify that. So when you simplify that, you actually can factor it, and you get 2 e to the x plus 1/8 e to the negative x, all squared under the square root, so the square and the square root can cancel, and you get 2 e to the x plus 1/8 e to the negative x from 0 to ln of 2, which is actually your original equation, so that's helpful. In your example, when you have this length equation, should be a lot easier than this. I'm giving you a hard example so you can be better prepared for the test. But anyway, so then what you're going to do is you're going to integrate like you normally do. And e to the x's are pretty easy to integrate because they usually end up being themselves. And then the negative one you just carry down. And then you end up getting 33 over 16. So for this next problem, I'm not going to go into too much detail just because it's straight out of your notes, but it's proving that the natural log of x times y is equal to the natural log of x plus the natural log of y. So basically what you're going to do is you're going to take this t substitution thing, and you're going to go from 1 to xy of 1 over t times dt plus the integral of 1 to x of 1 over t dt, and then plus x to xy. of 1 over t dt. So basically they're all 1 over t dt, but you're covering all the bases. So 1 over xy, 1 over x, and x over xy. And then you use substitution, t over x, and du is t dt over x. So then your u of x is 1, and your u of xy is y. And then you get ln of x plus the integral from 1 to y of 1 over ux times x du. And you cross out the x's because they cancel out. And then you get ln of x plus ln of y. I know that's super confusing. Honestly, what I did is I just memorized it so that it wasn't stressful for me when I had to take the test. But if you really want to understand further, I would go to Dr. Valderrama, or I would talk to someone else. But it's just something that's easy to memorize that you can get down so that you don't struggle on the test. All right. So this next one, it is a smart substitution. So you're basically trying to find out, hey, what do I substitute to make this as easy as possible? It's 5 ln of x over x. So the smart substitution here is u is ln of x and du is 1 over x dx. So then you end up with 5 u du, and then you change your limits of integration. So your bottom limit becomes ln of 1, which is 0, and then your top limit becomes ln of e, which is 1, because you're just plugging it into u. And then you integrate 5u, and you get 5 minus 1 equals 4. This will probably be with cosine and sine on the test, so just be looking over that, what your smart substitutions is, remembering that the integral of negative sine x equals cosine. 2s's, it'll help you with the negative. All right, well, that's all I have for you guys. I am sorry I didn't get to do a review class for you, but I hope that this helps you. I hope that you study hard, that you ask the Lord for wisdom and discernment on your test, and I will be praying for you guys, and I love you all. All right.